Thank you everyone for joining us today. My name is Daniel Azir. I'm a strategic application engineer at Markforged. Today I'm joined by a couple of additional hosts. Deep Singh from CAD Micro. Deep, will you want to give a quick introduction?
Yeah, thanks, Daniel. Hi, everyone. It's Deep here from CAD Micro. I'm part of the leadership team, spearheading our additive manufacturing vertical. I'm really excited to be here and share some of our experience and how we collaborate with Markforged and some of the initiatives and how we can help you guys in the Canadian market.
Awesome, thanks, Deep. And we're also joined by Joanne Gardner. I personally was really thrilled to hear about how Joanne has been leading a digital transformation local in Canada. Joanne, do you want to give us a couple words of introduction before we get started?
Yeah, sure. Thank you. My name is Joanne Gardner. I'm the director of the prototyping lab at Bayview Yards. We're an economic development agency in the city of Ottawa. We work with entrepreneurs from idea stage right through to scale up and international trade. And our team specifically helps clients bring their ideas to life. So we do prototyping and parts manufacturing.
Awesome. In case you guys were worried whether we had a superstar team, now you can be sure. So with that, let's get started. So what we have on tap for today, I'll first share a little bit about our perspective on the manufacturing landscape and how we fit in as a business and how CAD Micro fits in as a partner to Markforged. And then we'll cover a couple of customer examples, not the least of which it will be Joanne talking a little bit specifically about how Bayview Yards is utilizing the composite metal systems. And then we'll get into a little bit of the nitty gritty with the technology and the core components of that technology. And our goal is to leave a fair bit of time for Q&A and free discussion. To that end, you'll see in the Zoom interface, if you're not familiar, there is a chat box that gives you the option for a Q&A. I'm going to keep an eye on that. And personally, the way I like to operate is try to answer these questions real time. So just go ahead and lob them over and we'll try to track those questions down for you and keep it a free discussion. Appreciate those questions in advance, in fact. So with that, I'll get started again, talking a little bit about the manufacturing landscape. So I was a manufacturing engineer for a couple of years, starting in 2015. And even before the pandemic, we were seeing this sort of Amazonification of virtually every industry that's involved with making physical goods. And just to acknowledge for a moment what's happening in the world around us today, the pandemic has impacted every element of our lives in every industry that we interact with as a business. So to call those changes by name, I would first point to the fact that the pandemic is driving these unprecedented changes in the types of requirements that our customers demand of the products we produce. And again, this just intensifies a pre-existing trend with the Amazonification, necessitating both last mile supply chains and niche offerings for businesses to grow, where really that pathway looks like more product offerings, more customization. And you overlay that with already volatile labor conditions, with at least in the United States where I live and in Canada where I visited, gone are the days where you can quickly and accessibly find the skilled tool and die makers that are required in order to bring new products to market in any kind of substantial quantity. And then you think about supply chain and the way we've optimized it. We've really been optimizing for the wrong variable in the face of the pandemic, where we've been optimizing historically for cost alone, where we believe, and this is a Markforged opinion, that it's no longer the case that we can win in the market by providing the goods and services that we purvey through cost optimization alone. We've got to provide a combination of cost and lead time, as well as customer experience benefits in order to win in the market today. So as manufacturers seek out new tools in order to reinvent their businesses in the face of these challenges, we believe that continuity of a digital thread and the accessibility of parts is going to be key criteria in order to be successful in this next wave of a manufacturing movement that we see undergoing sweeping change in the industry today. So a little bit about Markforged. We exist largely in order to satisfy these needs for this ever-changing marketplace. We were established in 2013 out of Boston. Our founding team comes from MIT. We've won several industry awards. I won't bore you with the details, but Deloitte and Forbes both sort of point to us as one of the fastest growing hardware startups. And while I do in some ways consider us a startup, we're also a fairly established business. We get our support from a set of strategic investors that largely come from industry. So Porsche, Microsoft, and Siemens combined to help us to have raised $140 million. Most recently in 2019, we raised an $82 million Series D. And I say we're not just a startup, we're also sort of like an established business. One of the superlatives that we can claim is we have the world's largest connected fleet of printers. So when I talk about the continuity of a digital thread throughout the product lifecycle, this is one of the key elements that makes us the most powerful digital parts platform, really of any kind of fabrication platform that's accessible and available today. And for that reason, we're second place right now in terms of unit sales to date, quickly approaching the industry incumbent Stratasys that's been around for 3 decades. And this is to say we're not slowing down. We are continuing to accelerate the rate at which we innovate new products, and we've been rewarded with a really excellent share of the market as a result. Now what I'd like to do is turn it over to Deep. Deep is again an executive at CAD MicroSolutions, which is one of our resellers. We as a business distribute through a network of globally distributed resellers, with CAD Micro being our preeminent reseller in Canada. So Deep, I turn it over to you, man.
Thanks, Daniel. It's always great having this dialogue with Markforged and our customers and sharing some of our experience and where the direction of the technology is going. And part of the value-added chain that CAD Micro delivers to our customers is really helping customers realize the return of investment in their digital twin data. We've been around for over 35 years now as a company. The COVID has allowed us to expand in different parts of our country. So we're now coast to coast, and we recognize that there's a need of getting closer to the customers. So we have offices from the west all the way to the east. And Markforged partnership, we've been great at this resource here since 2017, helping customers realize the true strength of what they can achieve with composite parts, with metal parts, safe, easy to handle. But really, at the root of it, it starts from the digital twin. And how do we help customers maximize the return of investments in that capacity? And we've been able to build out a really strong customer experience center and portfolio over the years to help demonstrate that. So one of the approach that we do here at CAD Micro, we're really taking a value-added approach. It's more of a consolidative approach where customers will come to us and they have a requirement around their parts. And the first thing that we really try to understand is, what is your functional part requirement? Hardware is part of the solution, but understanding how the part is going to be behaving in the real world environment, that's the area where we start from. And then we line up the materials, the processes, all that to support the functional part requirement needs that the clients have. We offer benchmarking support, and that's part of the initiative to de-risk clients' investments. Typically you'll see a lot about 3D printing, but how do you know this is the right process, right equipment for you? So we can help you go through that process. We have built out customer experience centers that allow you to get hands-on experience. So, prior to pandemic, some of the pictures you're seeing, we would host in-person events, after-hour events, hands-on customer experience, all that. It's still available, but we have changed our approach on how we conduct these meetings. So instead of having these seminars that are in person, we can have one-on-one site visits. We can do virtual tours and really give you that full customer experience center. And then customer success is a big part for our growth. If you're not successful, then we're not successful. It's as simple as that. So, we provide you with the training, ongoing support, and we work as a liaison between Markforged and the customer. It's been working for us so far. We're really happy with our partnership with Markforged and continue to see growth in the Canadian ecosystem for additive manufacturing. And if there's any questions you have, please feel free to ask them. I'd be happy to stick around and answer those, or you can connect with us directly and we're happy to help you out there. Thanks, Daniel. Passing back to you.
Thank you, Deep. Very well said, my man. Yeah. So to both expand on what Deep said about sort of the engagement model and to peel the curtain back a fraction. So the way a lot of the conversations go when I interact with our customers is it's like, hey, Daniel, can you print this part? I really have a lot of enthusiasm about printing this part. I'm going to save a ton of money printing it. And while it is the case that generally with additive manufacturing, we can print the part for 10 times cheaper, cut the lead time by 95% or more. It's usually the case that when we expand the scope of what we're doing beyond just the part and consider both the entire value chain and the impacts to the business that are associated with that value chain, through indoctrination of design for additive techniques, of which Deep is an expert in, as well as use case identification, we start to breed this culture in organizations. I find that with this sort of additive first problem solving approach, we start to see businesses transform the very DNA that makes up their business logic to a far more creative and productive problem solving approach that yields truly transformational benefits. So I'm going to now transition to the part of our discussion where we're going to talk about how our customers are implementing the technology. I'll first start with the U.S. military. Again, I'm based in the U.S. and our president, Dwight Eisenhower, in the Second World War said it best: wars have been won or lost primarily because of logistics. The military faces some of the most challenging supply chain constraints, with or without the pandemic, that we can imagine. So how the U.S. Marine Corps is utilizing additive to combat these adverse challenges, it's probably no surprise to you all that to get something like a custom bracket to mount a radar on the front of an MRAP or Humvee, or to get a wrench to service a tank, it could take the Marines months or even the better part of a year to get a part in theater in the field of combat. So what they've done is they've made a program of record called XFAB, which takes these printers, both metal and composite, which we'll get into the specifics of the technology in a moment here. But they're taking this strong part fabrication technology and implementing it in the field in the form of these effectively like shipping containers. And they're solving real-time problems in the field as quickly as the problems come up. And the beauty of this is I mentioned a little bit about the indoctrination of design for additive techniques, use case identification, and ultimately the transformational business impacts that follow along with those sort of maturity hurdles that it takes to make your organization true additive first DNA. So while they started with this approach of, hey, I'm just going to print MRO anytime I need it in the field, they transitioned to more of an approach where hey, I'm going to digitize everything so that I don't need to wait for the thing to break and then engineer the solution and then print it. I can just print it as responsively as the problems come up. And now what they found is through the implementation of both lightweight lattices on the metal side and efficient continuous fiber parts on the carbon fiber side, they're optimizing the performance of their entire fleet of vehicles on the basis of both weight savings and improved durability for the field of combat. So with that example, I'm going to actually pass it over to Joanne, who can tell you a little bit more firsthand about what it's been like to implement this technology and making additive a part of their culture. at the Bayview Yards. So Joanne, take it away.
Thanks, Daniel. I like that you started with Amazonification. I first learned about prototyping, that's what we do, while working on solar energy projects in off-grid communities in the Amazon in South America and in Central America as well. And I really got to innovate, like witness innovation in design, but also the limitations on development when iterations can't be applied quickly, right, and rapidly. So access to local supply chains can drive business opportunities, but not having the right component to replace or replacement parts readily available really can cause a business to fail. And we saw that a lot. So that's really where, you know, now I get to see products evolve quickly, cost effectively, and with so much less risk every day. And that's what additive is really kind of added value to our side of our business. So the prototyping lab is really a test bed environment. So we're not additive only, but we do have a host of 3D printers, two of which are the Markforged and Markforged products, sorry, and a mix of traditional and and advanced manufacturing as well. And we also have a team of interdisciplinary designers who are the makers. And so they have that deep knowledge on when to use which capabilities to have that greatest impact for clients. And one thing to note as an economic development agency, and we are in Ottawa, Canada, is that we are funded. We're government funded, we're not for profit. And a lot of our equipment came through investments from the government of Canada and through FedDev Ontario. So we're actually really excited to add the Metal X by Markforged to our portfolio. And we've just added that in this fall. And we're really looking forward to putting it to use as our new workhorse here. So, and I know there's a lot of excitement in the city around it as well, because I believe it's the first one here. So next slide is really how our team and prototyping really relies on additive manufacturing in our type of business. So we work primarily at the early end of the product development cycle. So additive has really transformed that process, as I mentioned. You know, fundamental principles in prototyping is to build early and build often, right? Iterate, test, iterate, test, iterate, test. That's our mantra. And so getting quick designs into physical form to kind of interact with it for functionality, see it for visualization, size, product, it's particularly important to us. So tools like the Markforged 2 have really enabled us to refine and improve product design based on feedback, user testing, and lessons learned from early iterations. You spoke of speed and cost and ROI in your business. When working with entrepreneurs and early stage inventors, that's all they have, right? Isn't it? Or what they lack, I guess, is speed and cost. So anything that can shorten a time to market can increase the company's investment portfolio or potential, sorry. And seeing and holding a close to end use part or a prototype is the best way to get user feedback, but it's also the best way to reassure potential investors that your product is viable. Costs. So with Bayview Yards, we have a small fleet of different machines. So really it depends on fidelity, size, strength, materials required, but we always start in low fidelity materials, right? You want to develop that functionality first, and then we move into the higher grade materials. And so that's where the Metal X is really going to come in when we're, you know, solving for weight and durability, but we're able to test it in kind of these lower fidelity models first before getting to that end use part. Reliability and repeatability. It's so important here, right? The goal is to reduce risk for our clients, and precision is so important. When you're iterating, you need to kind of reliably control for specific variables. And if you don't have that repeatability, you lose a lot there. Optimization, you're speaking of optimization. So our designers are able to kind of design with the idea in mind and then the tools. So there are times, right? There are always going to be times where it makes business sense to fabricate something really, really quickly on a CNC mill instead of 3D printing. But what we've really seen with this Metal X is integrating precision metal into the prototyping process, right? Our team, our clients, specifically those for us working in the autonomous vehicle area, precision agriculture, healthcare sectors, they're really, they're excited because they see that opportunity to simplify their process, reduce complexity in their design parts before heading into mass manufacturing. And that's really important here. We're also an electronics lab. So the opportunity to custom design heat sinks and print in solid copper that we're getting from the Metal X, that's just a game changer for our IT and sensor hardware companies. So we're starting to experiment with that now, and we'll definitely have some use cases to report back to you in the future with that in mind. I love that you talked about creative problem solving, right? Traditional engineers are taught to design with limitations and constraints, but with additive, there's really no limitation to what you can design and build. And particularly with the Eiger software, we are seeing just the creation of parts that simply couldn't be produced by any other means. Our mechanical engineer, he's been loving that shift. He's had that opportunity now to shift to design for the Metal X, and it's really new to him. He wasn't designing for additive before. So 2 weeks ago, he wasn't designing for additive, and he's less worried about simple geometries, complicated shapes. He's able to take way more risks in his designs. And that was only after a few days of training. So really, it was really straightforward for us to bridge that gap to adopt the latest tech without having to spend a lot of years in new process development. And that's time that neither we nor our clients have to spare right now. And then I talk about kind of security, right? We're a very collaborative team. You know, we're a very creative team. We work really closely with our clients online. We do a lot of co-design session and really rely on digital platforms. What we've seen, especially with the Eiger software and our Markforged printers, is that we can design together in this software, but not just design. From home, we can launch our prints, right, to the Metal X and then come in. It means different designers can be dispatching different prints to the machine from anywhere and then printing them on a common bed. So if a time factor, it's really saving us there. And sensitive projects, it's really important with our clients. We support the Department of National Defense here in Canada and their innovation and defense practices. And they're one of our primary users of the Metal X. And knowing that their design files are secure is just an imperative to working with them. And I thought, just as a last little bit for us, I thought I would share just a little case study. It's more in the additive side of things, but this is one of our clients. It's funny, on my first day here at the prototyping lab, one of my coworkers was like, "I'm off to build a rocket," and I knew I was in a really special place. So they do a counter drone. This is AirShare. They do a counter drone missile. It's really the safest way to detect, confirm, track, and remove a drone that's posing a threat to people or infrastructure below. And it doesn't create any collateral damage. In fact, it opens up and netting secures around the drone and takes it safely to the ground. It's all very Canadian, we know. So Bayview Yards help them kind of guide through every phase of their prototyping journey, from their initial product to their design strategy, fabrication, iteration, validation. And we looked at lots of different processes and designs for them. And as many of you know, and probably in this experience, landing large government, especially defense contracts, is especially challenging, especially for small companies where, it's a vertical that's very established and large multinationals are in there all the time. And so they had very tight time constraints and budget constraints as well. So when we experimented with different materials to optimize for them, we ultimately decided to stick with 3D printing and the additive process, really because it decreases labor intensive for them from a manufacturing process from 12 weeks down to, a few days for a full print. So time and cost of materials, it decreases any opportunity for errors with them, but it's also a reliable supply chain. It's almost that you started to mention there, Daniel, as well, is you can have this on site, right? So if you are working in a military application, you can take a 3D printer with you to that site and print all the components there. And with the Metal X, we can finally move to a 100% additive solution for them. There were some small parts on the inside that were being manufactured on some of our CNC equipment, and we're going to be able to print them going forward. So that's a huge win for them and us as well. So in summary, the team at Bayview and our clients here have really benefited from our partnership primarily with CAD Micro and the relationship that they've built with Markforged.
Outstanding. Thank you, Joanne. That was awesome. Cool. So I'm sure we'll be referencing back to you as we get a little bit more into the nitty gritty of the solution and the scope of what we make. And with that, I'll transition a little bit. I talked a little bit about our customers' DNA and being additive first, which I think Joanne, it's safe to say, is clearly accomplished with Bayview Yards. Now I'd like to talk a little bit about our company DNA, because I think this is one of the things that really makes us unique. So whereas I think when I look at sort of the state of the state in additive manufacturing, it's largely mechanical engineers that are driving the innovations. Also, some really talented materials research scientists. I think what really makes Markforged unique is we have those core components in our founding team, but we also have this kind of interesting and fun free radical in David Benheim, our CTO, who is a software guru. And I think when our customers interact with our system, that's likely the thing that they notice that differentiates the solution from other additive capabilities out there. So our platform, which we term the Digital Forge, is this really tightly wound and neatly integrated sort of confluence of the enterprise software, excellent hardware for printing on, and best in class materials, ranging the full gambit of engineering problem solving. So Joanne was talking a little bit about going from mock-up to functional prototype to end use part. I'll talk a little bit about the specifics of the materials that we offer in the context of Digital Forge, but we sort of pervade that entire gambit for solving problems. So getting into a little bit about this software scope and solution. So when you first interact with our software, which we call Eiger, you'll first notice how lightweight it is. So it's all in the cloud. It's all accessible from a Google Chrome browser, and I can store my parts there digitally for free, as opposed to keeping my inventory on physically on expensive racks that I have to pay a monthly fee for. And as I provision this inventory and send files back and forth to and from the cloud, people like Joanne can say, hey, I can update these parts real time as I find better ways to optimize the part. I can take on new projects and organize those projects in a neat little folder. I can do version control. I can manage the entire fleet if I have multiple printers, like I mentioned the Marines do all over the world. I can manage that fleet from a single point of access in a single pane of glass, and I can manage all of the users that have that access. So as people in the field utilizing printers are pushing and pulling parts up and down from to and from the cloud, they can access these parts now anywhere, whether it be on-site or remote from wherever that business is. And the beauty of this is, and Joanne was hinting to this, is this is now for the first time unlocking some really productive work streams between not just intra-company, but also inter-company. So inter-organization collaboration, where let's say I make a high-value tool and design it for the first time to be printed. I can now make that part available for a fee to all of my customers out in the field that can now pay for what I'd call a digital token to access this part anywhere in the world. And the ways you can implement this solution architecture are really not limited in scope to how you configure the organization and the stream of parts and supply chain today, but rather businesses are thinking about how they can embed responsiveness, immediacy, and this sort of cloud first digital thread throughout their entire customer experience for tomorrow. So the beauty of this is again, I can snap my fingers, and as soon as a problem crops up, I can now access that inventory and have that part either same day, or in the case of larger prints or metal prints within 2 or 3 days. My inventory is now fully digital. I no longer have to pay for my parts ahead of time and have those parts on the shelf, even if I don't end up consuming them. I now can handle the governance of access of these parts and the ability to change these parts with really discrete role-based access control tools. Joanne hinted a little bit on security as well, and I mentioned we interact a lot with the military, and for that reason, we're the only company to have pursued in the 3D printing space to have pursued ISO 27001 certification that. For better or for worse, states that we as a business are following the best-in-class sort of industry standards, both with our software security as well as our organizational security. And to that, we also offer some off the cloud local area network access options for those ITAR restricted applications as well. And we don't stop there with our usage of the cloud. So our customers sort of liken our printers to a Tesla car, where we're constantly sending these cloud updates to the software that you interact with on a daily basis, the printers in terms of the speed with which you can print parts, the breadth of the materials that you can print through your printer. Joanne mentioned copper. That's something we launched last year that our customers were printing in steel, and one day they woke up and realized they could print in copper. It's like Christmas every time for me. You can see I have this carbon fiber printer over my left shoulder here. I still get giddy every time one of these updates comes back, and my printer has gotten smarter or more capable overnight. To wit, I'll talk a little bit about the print systems themselves. So our lineup consists of both composite printers, which have the capability to print uniquely in continuous fibers like carbon fiber and Kevlar, and then we have a suite of equipment that has the capability to produce fully dense metal parts, which includes a print system, a debinding station, and a sintering furnace. This whole sort of approach to printing metal parts was built off the backbone of a decades-old approach to making metal parts called metal injection molding. If you're not familiar with that, don't worry. We're going to get into all the steps of the process that are required in order to obtain a metal part. But this sort of comprises this fully integrated, tight-knit ecosystem of everything you need in order to produce a functional part. So the materials themselves that we print with, so we start with a polymer material on the composite side that we call onyx, which in itself is a really capable and functional thermoplastic polymer that's doped with chopped carbon fiber. So we use what's called an FFF, or fused filament fabrication architecture, where I'm extruding from a spool a bead of plastic through a nozzle. And then I'll use a separate and distinct nozzle and extrusion system to actually fuse in a continuous fiber into that polymer bead, which ends up with an end material property spec that aligns it more closely with 6061 aluminum. So I can now take these composite laminate structures that I've printed and plug them into an application space that probably would usually be reserved for metal. Beyond that, speaking of metal, so our metal print system is capable of printing stainless steel, a whole slew of tool steels, as well as some specialty alloys like Inconel 625. And as mentioned earlier, we recently added copper to that list as well. So before I get on, I see there's a question here. Anonymous attendee is asking, do you have some examples of printed parts you can show? How strong really are they? So to that, I do have a whole library of parts I'll show in a minute here, but maybe to answer that question a little bit more specifically, this is a chain link that was designed by a college that's local to us in Boston, and is really a design challenge that these kids took on. That was, hey, how strong can I design a chain link that has a square inch cross section? So that thing's about the size of two thumbs put next to each other, and you can see it popped right around 22,000 pounds in tension, which is about the equivalent of picking up 5 fully loaded Ford F-150s. So from a composite standpoint, again, this is going to play more in the application space that you would think of as like metal for the go-to. I'm now going to just do a quick additional video here to demonstrate how the metal print system works, because it is a pretty unique process. So if you're familiar with metal printing, you're in its more incumbent state with powder bed fusion, it might evoke some EHS or hazardous concerns. And what we've done is we've taken metal printing and took the feedstock powder associated with it and rendered it safe to use by binding it in the plastic feedstock material that we've become experts in extruding in the form of our composite print system. So this print system shares about 80% of the bones of our composite system. So we have this metal powder in this feedstock material, and then we debind it in this wash station, which is again a product we make. And when we pull out that binder system, we then put it into a sintering furnace. Again, another component of the Markforged ecosystem. And this furnace, which again is also connected to this ecosystem, then ramps it up to a high enough temperature that the metal powder particles that were encased in that filament now can diffusion bond together into a solid homogeneous body. And I can remove the supports and all the other sort of vestigial structure by hand. No longer needing to do things like EDM wire to machine off and the support structures that were needed to produce that part on the printer. So seeing another question here, can I print parts of a functional planetary transmission, so planetary gearbox? So the answer to that question from an application standpoint is sort of dependent on the parameters of the part itself. So in the case of our 17.4 stainless steel, here's what we're looking at in terms of the specifications, in terms of hardness, tensile strength, yield strength. We do see people taking these parts, machining them down to the critical tolerances. It probably bears mentioning the accuracy of these parts is sort of akin to a casting. So we'll see people do things like print the part on the metal print system, machine off the critical tolerances, maybe like where you like the spline for the shaft, as well as some of the interfacing surfaces on the teeth. And then they might do a heat treat or case hardening, or in the labs we're also experimenting with boronizing our metal printed parts, and then plugging them into the end use case. Because the reality is, when people ask me what makes a good use case for our print systems, both composite and metal, it's really not limited to what the part is, but really how the part functions within your supply chain and your value chain as a whole. Because the universe of parts that we can print and what's technically achievable on the system is so broad, it's really starting to understand the intersection of the parts where we're delivering that immediate ROI, as well as where these sort of transformational impacts and performance benefits start to come into play. So while tools and fixtures are sort of the low-hanging fruit, we also start to look at things like aftermarket replacement parts. So for things like gearboxes and housings and brackets, and as well as end-use components that adapt more with more agility to the changing demand signals that our customers see in the market. So I'll conclude with just a couple more notes about our software. I talked a little bit about the solution architecture. So our software, which we again call Eiger, when we set about sort of like thinking about how our system interacts with the rest of the manufacturing supply chain and value chain, we recognized that modern equipment, falling into Industry 4.0 initiatives, modern equipment in the manufacturing workplace needs to be smart, connected, accessible, and scalable in order to mesh well with the kind of things that people are doing on a daily basis. And for that reason, this software platform is not only accessible from the standpoint of hey, I can anywhere I can log into Google Chrome, I can log into Eiger and print my parts or manage my digital inventory. I can also use tools like our API endpoints to integrate with whatever MES or MEC software is being utilized on the manufacturing floor. I can also do real-time monitoring of the fleet to be able to give me salient metrics of what the fleet and what my users are doing with it, as well as monitoring the uptime. And most critically, I mentioned the notion of updates. So these devices are not only receiving updates and getting smarter every day. We're also monitoring real time all of these devices that are on the network. I mentioned we have over 10,000 nodes on the network of connected devices that distinguish us from any other digital parts platform out there. We're taking that data and using it to make the system smarter on a daily basis, so that when we make these updates, we're doing so in a way that maximizes the end user value. So in closing, when we started down this path back in 2014, the types of use cases we best supported were a combination of concept models as well as some functional sort of like aluminum replacement parts. But we didn't stop there. And in fact, we very quickly took on far more ambitious use cases with the types of problems we could solve. So as we sort of advanced down our own company maturity model, we brought into the scope of what's possible a far more comprehensive list of things that sort of match what I'd call sort of the intersection of what's valuable and what's technically achievable on a print system. So that's the end of what we had in terms of slides. Again, I invite you all to continue to pour in questions into the chat box. I see we have another question here about the technical properties of the part itself. Is the finished sintered part porous, or does the metal bind away the layered gaps, remove filler material? I'll start by again acknowledging that the part is going to be akin to a casting in terms of both the accuracy and the properties. So like a casting, we'll see a porosity on the order of 2 to 4%, depending on some of the specifics of the part and the material we're producing. One of sort of the interesting things about utilizing 3D printing to produce these parts is there's no rule in the book that says I need to have the part be fully dense. That's to say, like the volume subtended by the shell of the part doesn't need to be filled with material. In fact, most of the prints that come off our print system in some way utilize a lattice or a honeycomb structure that in cases where mass or heat transfer is of importance, that lattice plays a major role in the performance of the part itself. I see another question coming in from Roger. Are the stainless steel products food grade? So while we are currently investigating the types of regulatory hurdles that are required, mostly on the materials traceability front, in order to certify the stainless steel that we make for food grade applications, we're not quite there yet. But stay tuned for updates in your manufacturing or 3D printing journal du jour as we continue to accelerate the nature of our compliance for some of these more regulated industries as we start to take up more of the low-hanging fruit and look toward more production applications.
Daniel, while we wait for some more questions to come through, I just wanted to share sort of the story around how we leverage the Eiger software in our business. We're coast to coast in Canada. So, at CAD Micro, I have tech team that's based out of Alberta. I have tech team that's based out of Quebec and in Central and Ontario. And part of the learning experience when we bring on new technicians on the team, we need to do a lot of engagement and collaborative work, and they might not be in the same room together. So the Eiger software really allows us to send files to our print farm in different part of the country, and we could be in real time collaborating on a customer benchmark and saying, hey, maybe we should put fiber reinforcements this part of the region, or maybe we should be printing this out of copper instead of a different material. All of that collaboration can happen in real time, and then we can dispatch files similar to like a fax machine, but now instead of receiving paper, you're receiving tangible parts. So that's been very instrumental in bringing our technical staff up to speed with their knowledge. And I'll share with you, in 2018, I was at Formnext at one of the largest trade show that happens in Germany for the additive community. And we had a customer that had the budget and wanted to immediately do a benchmark to impress the executives in his company. And I wasn't on site at the time, so I dispatched a file from Frankfurt Airport, And by the time I arrived at Pearson in a couple of hours, the part was sitting in the printer, and we had a meeting before I went home, and they ended up walking away with the printer. So there's really exciting elements to this about the digital inventory management, collaborative efforts that you can do in real time, especially because now we're dealing with pandemics. It's even more crucial that we adopt this sort of mechanism. So I thought I'd share that with the group that's attending today.
Awesome. We got a question for Joanne. Joanne, if you would be so kind as to address this question, how does Bayview Labs think they will expand as they start to build up their additive manufacturing capabilities?
That's an interesting question. So where we want to be able to grow is, so we support early stage, idea stage companies, but as we build out our capabilities, the opportunity for larger organizations to be able to collaborate and create some of that supply chain opportunities for those smaller companies, as well as government as well, right? Being a large government town in Ottawa. So how do we create those supply chain opportunities for those companies is one of the areas that we definitely want to play in more. And I think these tools are where we're going to be able to do that sooner, especially as we were mentioning with defense contracts, that type of thing. The other piece for us is our new site, Area X.0. It's the Futureplex of innovation in Ottawa, and it's really around digital innovation. We have an autonomous vehicle test track. We have all the mobility equipment there, 5G, a mobile 5G testing, a precision agriculture testing. It's all site in one area. And so to be able to, come to the track, test out your equipment, be able to then, come over to the prototyping lab, make any changes to the parts that you may need to, that failed quickly, and get back on the test track right away is where we see ourselves kind of growing next.
Awesome. That's super exciting. Just to hear how firsthand how organizations are adopting additive and how they're growing with us. I see another question about sort of the usage of stainless steel. Do you have different surface polish options for the 17.4 stainless steel? Yeah, so in general, especially for production use cases, people will do a whole number of processes that you might do to a casting in order to get it production ready. One of the kind of unique things is, so I mentioned when it starts out, it comes off the printer as sort of almost like a sandcastle of metal particles. So you've got your metal particles in sort of this waxy, plasticky binder system. So the part takes on the consistency of that binder system. So what we sometimes do, and if you've seen like Markforged copy ads or images of like a brake lever we printed in steel, sometimes what we do is we'll cheat a little bit, and we'll actually wet sand the part while it's in this what we call the green state before we sinter it, and it's still soft and workable, and you don't need a high-speed cutting tool to change the shape or the appearance of the part. So in doing so, we remove a really small amount of material, but we lend this really high-quality surface to the part that doesn't take any tool time or secondary process. But yeah, any kind of like bead blasting, machining, polishing, all of those types of processes, as would be the case for casting, are fair game with our metal printed parts. Okay, I see another question coming through here. If I was interested in understanding how this might help my manufacturing business, what is the process with working with the team, presumably CAD Micro largely, as well as Markforged as sort of backstop support? do you come on site currently? Can I give a video tour of my of my factory equipment that I'm looking to upgrade? I think I'll leave it to Deep to answer the specifics of how you guys operate today in the face of COVID. So Deep, you want to talk a little bit about how you guys engage currently and what the future state might be once things are a little bit more normalized?
Yeah, no, this is a really great question. So we have lots of different options available, depending on type of facility that you're at. You know, if there's a COVID policy in place from a health and safety standpoint, then we could potentially do on-site visits. We have kept our doors open as essential support company to provide for personal protective equipment companies that are supporting others. So you can come to our site. We can review equipment. But if virtually is really the way, and that's most convenient and comfortable, then we can do virtual site visits. Part of what we have deployed during the pandemic, working with our customers, you know, we had to do industrial scale printer installations on the other side of the country, and our team couldn't go there. So, you know, collectively with the client and CAD Micro, you know, we did the AR installation. So our customer was wearing their headset, we were wearing our headset, and in real time we could use collaborative work like that. We can also deploy that for on-site virtual tours. So where we can put on these glasses and give you a point of view, go really deeply into the machines if that's something that's required. So there's a number of creative ways that we can continue to offer you know, experience to our customers.
Awesome. Looks like the questions are slowing down. I was asked earlier on to show a couple more examples of strong parts. So I feel like I probably got off the hook a little easy just showing pictures of the parts. I'm on camera here, so I can actually show some real-time pictures. I'm just going to go spotlight here. Continue. Cool. So I talked a little bit about how the military is using our technology. So they have a number of assemblies that require these highly customized wrenches in order to access these hard to reach areas that are perhaps intentionally designed to be a little bit tamper-proof. So they require these custom fittings. So this is an example of, and you can see we've got the sort of high quality writing there on it says carbon fiber on it. But this thing is about as strong as aluminum again, and it doesn't stop there with making these highly customized wrench geometries. So I mentioned they're utilizing both composite and metal parts. What we see really commonly is what we call a hybrid part approach, where people are using carbon fiber for the components that require stiffness, and then using metal for the components that require local hardness. And so we're putting together these components with bolts, sometimes magnets, sometimes little detents. In this case, you can see on the inside there, I have a little detent. So for style points, when I put this thing in, it has this really satisfying click to sort of give you the idea that this thing's really secure in there. And I can go, I have a set of bolts on this box here. I can now go unfasten this thing. And so, yeah, just another example of high strength parts that people are printing with the technology there. Share one more.
Daniel, while you're sharing, maybe talk about the hybrid approach that we're starting to see people use in a combination of composite and metal. That seems to really take off in some of the applications.
Yeah, it's a great question. So when we think about the technical requirements of parts in different applications and use cases, I sort of discretize it into 3 or 4 buckets. One is tensile strength in a plane, which is great for anything that's a laminate composite like carbon fiber, both traditional and printed. And then there's tensile or flexural strength in multiple planes, which may still be a suitable application for composites. but sometimes multiple axis loading conditions make it a better fit for metals. And then there's requirements like hardness and temperature resistance. So whatever the case may be, the strategy that a lot of our customers are taking on is because the metal part is a multi-step process. You're generally better off discretizing the metal component into the most discrete, small, efficient print you can make it, and then where possible using composites as effectively almost like 3D duct tape, albeit really high precision and high quality duct tape. So I can make sort of the outer shape I need in the composites, and then I just put the metal where I need local hardness, local temperature resistance, or resistance to 3 or more axis loads. So this is not limited to things like wrenches, things like end effectors, jaws, grippers, even welding fixtures that are exposed to really high temperatures or a high degree of weld spatter. All make for great applications for this hybridization approach, where you're taking the best of what the two component technologies do in their very best form. Cool. So I see the questions are starting to slow down, and we're coming up toward the top of the hour here. So if there are no other questions, I'll probably sign off and give everyone a couple minutes back in their day. Certainly appreciate the questions and the participation today. Certainly makes it more fun for me. Any last closing thoughts from the co-hosts here, Deep, Joanne?
Yeah, I just want to say thank you to Joanne and Daniel for putting this together. I know the stuff that Joanne and her team is doing at Bayview Yard is very impressive, and we're going to continue to build off that success there. And I really enjoy sort of our collaborative work that we do with Markforged. So, and I want to thank everybody that attended today, because without the attendees, it's not it's not nearly as fun as it is right now. So appreciate everyone that's on the call today.
Yeah, and I'll just echo the same as Deep. It's great to be involved in this, to tell our story a little bit, but also I learn so much more about the technology every time I speak with both of you. So I know that it always helps us get a little bit further with our clients. So thank you very much.